Okay, so we're going to continue in section 2.1 and we're going to talk about the domain of a function. Basically, the domain of a function is the set of all possible values that the independent variable can be. So when you look at the domain of a function here, the independent variable is x. On all of these, the independent variable is x. I could have varied this and made the independent variable be different letters like t or z, but I went ahead and used x. So here you have x squared minus 2x plus 1. The question you have to ask yourself is there any value that I cannot plug in to this? In other words, will I get a real number if I plug, say, 1 into this? Well, 1 squared minus 2 plus 1 is a real number. Or negative 2. Negative 2 squared minus 2 times negative 2 plus 1 is a real number. Basically, any number here that you plug in for x is going to give you a real number for y. So for this particular function, then the domain of this function is all real numbers. And I'm going to show you the graph, but you shouldn't cheat and look at the graph to determine this. I'm just going to show you the graph so that you can see the relationship. So here's the graph, and notice that it goes on forever and ever in the negative direction, and for the x values, that is. And then if you go to the right, the x values continue, and basically every x value is included. So if I went infinitely to the left and infinitely to the right, every x value is included. So the domain of this function is all real numbers. Okay, this function here, y equals square root of x minus 5. Remember that x minus 5, since it's a square root, x minus 5 has to be greater than or equal to 0. And actually I should have greater than or equal to 0 here. Okay, so x minus 5 must be greater than or equal to 0. You can't take the square root of a negative. So whatever's in the radical must be greater than or equal to 0. And then to get the domain, you actually have to solve that inequality for x. And the domain is all values that are greater than or equal to 5. So x can be any number 5 or greater. And if I show you the graph of that, you'll see. If you look at the graph, this blue graph here is the graph. And notice it starts at 5. And then if you go to the right, you get, you can go as far as you want, and you'll get, any x value. So you can plug in any x value greater than 5 or 5. You just can't plug in any numbers over here. Notice there's no corresponding y values for 4 or, any number less than 5. There's no corresponding y value. So the domain for this would be all x values greater than or equal to 5. And of course, you know how to put that in interval notation if you need to. Okay, this y equals 3x minus 2, this is actually a linear function. And by the way, this up here was a quadratic function. The domain here is also all real numbers because there's no number that you can't multiply by 3 and subtract 2 from that won't give you a real number. So no matter what number you plug in for x, you'll get a real number for the y value. And we can see that if we look at the graph. Here's the graph of that line. And so you can put in any positive number, because it goes on forever and ever and ever to the right. So I can put in any positive number. I can also enter any negative number, as well as 0. So I can enter any number in here and I'll get a y value. I'll get a corresponding y value. So the domain of this number is all real numbers. Okay, the next function is actually a rational function. And remember from the earlier videos, you can't have 0 or you can't have the denominator equal 0. So you have to say what would make this denominator equal 0, and that number is 2. So the domain of a rational function is basically anything, all real numbers except those that make it 0, make the denominator 0. So x cannot equal 2. That's the only value that x cannot be. Okay, so if we looked at this graph, you'll notice, and I can give you a better picture here if I graph the line for x equal 2. Okay, so I'm going to back out here in a minute, but notice that as you get close to 2 from this side, the graph seems to go down, 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 down. And as you get close to 2 from this side, the graph tends to go up, 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 up. So if you back out, I mean, you may think it's touching, but it never does. I mean, if I chose a number very, very close to 2 on this side, like let's say I chose 2.00000001 and plugged it into this function, I would get a very large y value. But if I plugged 2 into this function, it's undefined. So this function is defined for all numbers close to 2, but it's not defined for 2. So the domain of this function is all real numbers except 2. To get the domain of this number, it's a little bit like this one up here, except that here you have a quadratic. And so what you have to do is you have to solve the quadratic inequality 9 minus x squared must be greater than or equal to 0. And I solved one similar to this. Basically, this is also saying x squared must be less than or equal to 3. So, x squared must be less than or equal to 9. So anyway, it turns out that if you solve this, I'm not going to solve it here, but it turns out if you solve this, basically your answer would be x has to be less than or equal to 3 and greater than or equal to negative 3. So it turns out that the domain are all values from negative 3 to 3, because if you plug numbers outside of that range, that domain, if you plug numbers outside of that, you'll actually get a negative under the square root, and that leads to a non-real number. Now graphically, this is what the graph looks like. It's basically just a semicircle, and notice that the x values run from negative 3 to 3. So you can get a y value basically for every value of x that you want from negative 3 to 3. So the domain here would be all numbers from negative 3 to 3. And of course the bracket tells you we actually include the negative 3 and the 3. Okay, this last one here, y equals x over x squared minus 4, it can be rewritten as x over x plus 2 x minus 2. And you can easily see that when you have x over x plus 2 and x minus 2, that if x is negative 2, this is going to be undefined, or if x is 2, this is going to be undefined, because it will make your denominator equal 0. So therefore, the domain includes all real numbers except plus or minus 2. And if we look at the graph of this, y equals x over x squared minus 4, you'll notice, let me go ahead and inlay the values that x can't be, 2 and negative 2. So notice, you'll see this vertical line right here and this vertical line right here. That's where x equals 2 and negative 2. Well, you'll notice that at negative 2, as you get closer and closer and closer to negative 2, you get it just gets very, very small. It keeps going down. But as you get closer and closer to negative 2 from this side, it just keeps going up. So in other words, you can get as close to negative 2 as you like, but x cannot equal negative 2 because that would make the denominator 0. Also, the same thing's occurring with positive 2. You can get close to 2, but you can't actually ever get there. X can never equal 2 in this example. So the domain of this function is basically all real numbers except x equal plus or minus 2. Okay, I want to wrap up talking about the vertical line test. And basically, a relation is said to be a function if no vertical line crosses it more than once. Let's go back and look at some of the graphs that we just looked at. Okay, here's the first one. This was the quadratic function. And I drew this vertical line right here, and I made it a dotted line so you could differentiate. If you move that line through there, notice that vertical line never crosses it more than once. It only crosses it once. So that, my friends, is a function. Okay? Let's look at this one. Okay, now, all right. I don't have it going all the way out there, but notice that no matter where I move that vertical line, it's not going to cross it more than once. Okay? All right. Let's look at the next one. Y equals 3x minus 2. Let's get my vertical line over here. All right, the vertical line only crosses it at most at one place. All right, then the next one. Okay, let's turn the line off. Okay, so the vertical line, whoops, I turned the wrong one off. All right, so you see the vertical line, it never crosses it more than once. See, so it never crosses it more than once. So that's a function. The next one, same thing. The vertical line never crosses it more than once. And hopefully you kind of get the picture now. The vertical line crosses it no more than once. Oh, I still got that one turned on, but okay. That's all right. I think you can still see. Okay, so here, this is a function. Okay, this is not a function. See how the vertical line crosses it more than once? So that's not a function. This is not a function. The vertical line crosses it here and here. And this is a function. Okay, now real quick, the horizontal line test will tell you whether a function is one-to-one. And let me show you that. Okay, I need a horizontal line. So let's say y equal 2. We'll start off with that. And let me turn on one function here. Okay, so there's a horizontal line. Now you can see that there's lots of places where this line crosses the graph more than once. So therefore, this function is not one-to-one. Okay, this function is one-to-one because the horizontal line only crosses it one place. This function is one-to-one. Okay. This function is, let's see. Yeah, this function is one-to-one because the horizontal line only crosses it once. This function is not one-to-one. You can see the horizontal line crosses it more than once. Okay, and then finally the last one. Let's see. Okay, so this function is not one-to-one. You can easily see right here it crosses it here and here, so it's not a one-to-one function. And if you were to do the same thing here with my graphs, with a horizontal line, this line here crosses it only once no matter where you're at. This one doesn't matter because it's not even a function, so it can't be one-to-one. Same thing here, it's not a function, so it can't be one-to-one. And then here's a function, but it's not one-to-one because the horizontal line crosses it at more than one place. Okay, so that wraps up video number 2 on section 2.1 functions. And the next video we'll talk about function notation.